8.2, we are going to talk about the Pythagorean theorem and its converse. Okay, before we get into that, though, we are going to review the parts of the right triangle. We briefly talked about it in 8.1 when we were doing the geometric mean with the altitudes. But being able to identify the two different parts of the right triangle is going to be very, very important throughout this whole chapter. Okay, so the first part that you're going to need to identify is going to be this side that's opposite the right angle in the triangle, and that is called the hypotenuse. Okay, it is always the longest side. Okay, and like I said, that is going to be the most important side to pick out when you're doing things throughout chapter 8, but especially with Pythagorean theorem. Okay, the other two sides that actually create the right angle, okay, those are called the legs. As we move through this, being able to identify those two legs as A and B, but then again, that hypotenuse is the C value, is going to be very important for your success in this chapter. Okay. Now, if we have a right triangle, okay, so we have to know that it's a right triangle first. Then we know that the sum of the square of the legs, okay, so our A values is going to be squared, our B value is going to be squared, is going to be equal to the square of the hypotenuse. And that's where we get the A squared plus B squared equals C squared. Okay, so here when we go down to work some of these examples, I like to pick out my C value first. It's always opposite that right angle. Okay, it does not matter which side you make A, which side you make B. But then we're going to substitute our values in to the Pythagorean theorem. Okay, I said 6 is my A value, 15 is my B value, and X is my C value. Okay, exponents come before addition and subtraction in our order of operations. So 6 squared is 36, 15 squared is 225. When I add them together, I get 261. Okay, and then finding the square root of both sides tells me that this is 3 square roots of what? 29. 3 square roots of 29. Okay, and we can review in class simplifying radicals if we need to, because simplifying radicals is going to be important. Okay, example number 2 here. Again, I like picking out that C side first. It's always opposite the right angle. Okay, so 11 is my C value. It does not matter which I make A and which I make B after that. Substitute X in for A, 9 in for B, and 11 in for C. Okay, exponents come first. So I square both of these parts. Okay, now when I'm solving for a leg, I have to subtract that other part. Okay, so X squared is going to be 40 in this case. Square root of both sides tells me that X is 2 square roots of 10. Okay. Example 3 looks like I'm trying to solve for the hypotenuse first. Again, just like in example number 1. Okay. I'll make 17 my A value, 7 my B value. substitute them into my Pythagorean theorem. Okay, 17 squared is 289. 7 squared is 49. When I add them together, I get 338. Okay, and then the square root of both sides will get me my the length of my hypotenuse. All right, example 3 here. I know my hypotenuse, but I'm looking for a leg. Okay, so I substitute in 22 squared is 484. 25 squared is 625. I'm left with x squared equals 141. And square root of both sides tells me that this other leg is equal to 141. Square root of 141. Excuse me. Okay, so that's basic Pythagorean theorem. If you know that it's a right triangle. Okay. And you know two side lengths, you can find that third one using the Pythagorean theorem. Okay. Now these Pythagorean triples, these are just shortcuts. Okay, don't feel the need. Don't feel like you have to memorize these. Okay. But a Pythagorean triple is just a set of 3 positive integers that makes the Pythagorean theorem true. Okay, so if I take the 3, 4, 5 triple here, that just means that 3 squared plus 4 squared equals 5 squared. Okay, and those 3 numbers represent the side lengths of my triangle. 3 and 4 are the legs. 5 is my hypotenuse. Okay. And not only are these 4 sets here triples, but any multiple of them is a triple as well. Okay, so here, for instance, this one, if I multiply all of these by 3, 5 times 3 is 15, 12 times 3 is 36, 13 times 3 is 39. These can also be 3 side lengths of a right triangle. Okay. So again, those are just shortcuts. You don't have to memorize them, but they might be helpful for you. Okay. Word problems now. Example 1 says Damon is locked out of his house. The only open window is on the 2nd floor, which is 12 feet above the ground. Okay. He has to place a ladder 5 feet from his house. Okay. And he needs to know how long of a ladder he needs to borrow from a neighbor. Okay. Anytime we've got a ladder, it's going to be the hypotenuse. Okay. So 2 options here. You can, if you are good at memorizing and you recognize this as a Pythagorean triple, 5, 12, 13 is a triple, so that ladder would need to be 13 feet long. Okay. But if you don't know the Pythagorean triples and you just need to do the Pythagorean theorem, that's fine too. Okay. 5 and 12 are your A and your B values. So 5 squared plus 12 squared equals what squared? 5 squared is 25. 12 squared is 144. When we add them together, that's 169, and the square root of 169 is 13. Okay. So again, you can know the Pythagorean triples, and it's kind of like a shortcut, or you can just use the Pythagorean theorem. Either way. Okay. Example 2. According to a company's safety regulations, the distance from the base of the ladder to the wall that it leans against should be at least 1/4 of the ladder's total length. If you are given a 20-foot ladder to place against the wall, okay, so again, that ladder is going to be the hypotenuse. We need to know the maximum distance up the wall. Okay? Now, remember, the ladder should be a fourth of the, the ladder needs to be placed at least a fourth of the distance that the ladder is long. Okay, so 1/4 of 20 is 5 feet. Okay, so 5 is what's going to be one of our legs. We're looking for the other leg. And the length of our ladder, the hypotenuse, is 20 feet. Okay, so 5 squared is 25. 20 squared is 400. Since I'm looking for a leg, I've got to subtract from both sides. Okay. 400 minus 25 is 375. And the square root of 375 is 5 square roots of 15 feet. Or if we want to put this word problems, we like to put in terms of decimals, because in the real world we usually don't talk in terms of square root. This is going to be 19.36 feet. Okay,